Well, hi, boys and girls, and welcome back to another exciting school year. We're going to jump right into it, and this will be the first lesson, and this will actually be a review lesson. But the first unit we're going to get into, and it's going to be a lot of the reviewing a lot of the concepts that we discussed last year. But just applying them to a different scenario. But our first unit in AP Physics 2 is going to be hydrostatics and fluid dynamics. And the second video that I have will get into a little bit more of the nuts and bolts. But one of the things that you're going to find as this year continues to go, and we will see a lot more than we did in AP Physics 1, but there's going to be a lot of scenarios where I'm going to ask you to graph things out. So we're going to have to dust off our skills in Excel and then even handwrite some of the graphs out as well. So sometimes it's easier to do it in Excel first and then to actually transfer it over to just a handwritten form after you've already seen what the line looks like. So anyway, let's get right into this. All right, so last year we kind of learned several different graph types. And we're going to see these over and over and over again this year, but you're going to have to understand this and be able to recognize the graph types very quickly in order to save time as we're getting through this. And honestly, when it comes down to it, as I'll talk about here in a little while, it really comes down to the equations that we use in physics, and you should be able to recognize based on the equations exactly what type of graph you're going to get anyway. So this is a skill that we've just got to become very efficient at as the year goes on. Okay, so different graph types that we have. First of all, we got our linear and proportional, and these are very similar, but with our proportional graphs, that means the x and y variables are proportional to each other, so hence we do not have a y-intercept. Okay, so the linear and proportional graphs are going to give us straight line graphs. This is one that, of course, everybody wants to see the first time through because obviously you don't have to manipulate the graph type. The power curve or the x-squared graph or the quadratic, you end up with an x-squared graph. You're going to have the y equals mx squared equation for your line when this is all said and done. And remember, each type of graph that you end up getting tells you exactly what you're supposed to end up doing to the independent variable. So this is an x squared graph, so we want to be able to square the independent variable to get the line to straighten out. We'll see several root curves this year, so you have your y equals m times the square root of x, so your x-axis variable will be square rooted. You have the inverse curve where it starts high and finishes low. So you just inverse the x-axis value, and then inverse square, y equals m over x squared. We saw one of those last year in our gravitation unit. We'll talk through that here in just a little bit. We will see other types of graphs this year. We'll see an inverse cube as we get moving through. I think that is in the magnetism unit. And we'll see some logarithms too when we get to capacitors and electric circuits, which is another topic we didn't get to at the end of last year with the electric circuits, so we'll have to start from scratch on that particular unit. So once again, the equations that we use tell you exactly what type of graph is going to be generated. You look at any physics equation and they're going to tell you. Just thinking of something real simple, we have the equation delta x equals 1/2 at squared, one of our kinematics equations. Well, if we plot position as a function of time, you got delta x and you got t squared, so we should expect that we'd end up with a power curve out of that, so we're going to have to square the time values in order to straighten the line. Okay, so once again, when we're graphing these variables, you have to kind of think about what the equation is that we're actually graphing, and you should know what's going to happen before we even get to that point. So we'll build on that as we continue going. All right, so this is the one thing that a lot of students always forget, and it drives me crazy as a teacher, but we need to make sure that we know exactly what's going on when we're doing labs and when I'm asking you to graph, because students end up putting things on the wrong axis. And you also have to be careful about the way we collect data. Sometimes we collect data in reverse, so the independent variable, when we graph, I may want it as the dependent variable. So you always have to look at what I ask you to graph. So when I give you a graph title, they are always written as dependent versus independent. I may say this as a function of this, and if I say that, then it's the same thing. It's dependent as a function of the independent. So when you go to Excel, though, The independent variable will always be placed on the left-hand side of the data table. So you need to understand that when you get to Excel, you're always going to place the second term to the left-hand side. So pretty much independent goes in column A, dependent will go in column B when you are doing your data tables. When we create the graphs, we always want to use scatter plots. For some reason, Excel ends up making it all funky looking if we try to use line graphs. So always use the XY scatter plots when creating Excel. The type of scatter plot used just kind of depends on what exactly we're trying to get out of that particular graph. Sometimes we use the straight scatter plots. Sometimes we will just use the one that's smooth curve. That's the one I usually use. So anyway, when you place the independent variable in column A on Excel in your data table, it will always be placed on the x-axis of the graph as long as you select the scatter plot function. So that's going to automatically place it there, so you know exactly where you need to put all of your data. Once again, as I said in the last slide, manipulating the data is pretty easy. If your first graph's not linear, all you have to do is just look at your graph type. If it's an x-square graph, then whatever your independent variable is, simply square it, and it should straighten the line out. If it's an inverse graph, inverse the independent variable. If that doesn't work, you might have to inverse square the independent variable. It just depends on the type of graph that you get. You might have to change it a couple of times in order to get this line to straighten out. All right, so let's look at one example real quick. Let's say a student was asked to plot velocity as a function of displacement. And, excuse me, you end up with a root curve for the graph. Okay, so if I ask you to do this, velocity is a function of displacement. When you go into Excel, you are going to want to put displacement. So delta x is going in column A, and velocity is going to be in column B. Now, when you get into Excel, make sure you also place units in parentheses in those two columns, okay? You do not have to place units on any of the numbers below. Matter of fact, if you do so, when you get into Excel, it will not like that when it's trying to plot it out. So only place your units next to the variables and then plot your graph out. Based on this, you will get a graph that will place delta x, and then you would end up placing your parentheses here and put meters, and then you would have velocity on the y-axis, and this would be in meters per second. Okay, and this will give you a root curve based off of what it stated on this. Now, it could be different types of graphs, but for this particular one, it's going to give you a root curve. Okay, so if you plot these variables, this is the resulting graph type. It tells you exactly what you need to do from then on. Okay, so I'm going to go ahead and clear this out. So based on that root curve, you know you're going to have to make a second data table. So now you're going to have to make a square root of delta x, and velocity goes there. So now we will have a velocity as a function of the square root of x, and based off of that, you will get a straight line graph from that. Okay, so there's delta x square root of and velocity, and once again, now you're going to have to put your units onto that. In Excel, trying to get the unit for square root of meters, and Excel sometimes putting the square root symbol in there. You can use several other things, okay? So there's lots of different ways to represent that. So just choose what works and how it's going to be easy for you to be able to do. Okay, all right, let's move on. I'm going to go ahead and clear out of that and allow myself to get moving on here. Okay, next, writing equations for the line. This is the next step, and this is the most important one. After you get your graph done, you will place a trend line on there. So once you put the trend line, you're going to get a little y equals something times x value once you get your straight line graph. When you're writing your equations, I know it's y is equal to the slope times x, but y and x will not actually go in your equation. This is the point where we are actually writing the equation based on our line. So if we go back to the last one, we would have v equals some number times the square root of x. Okay, So the slope of m, when you insert your equation into linear plot, slope magnitude has a meaning. That's when you're going to have to figure out what that meaning of the slope is. Maybe more than one variable. Okay, so once again, if we think back to what we learned last year, and you start thinking, let's just make up a number here. Let's go back to the last example we had. So we had on our y-axis, we had velocity, so we would put v, and we would say that's equal, and let's say my slope number was a random number of 2. And we'll go to 2 sig figs on this, 2.0. All right, now what we do is leave some space in this, and then we know that this is the square root of displacement. Okay, so that is the starting point for this. Okay, so once we're to this point, trying to figure out what this unit is can be a real pain in the rear. Okay, sometimes it's really easy. Other times it's going to be very, very difficult to be able to figure out. You've got a couple of different options. Option number one is to isolate the slope number. We can divide by delta x over here. So if we move this over and we say v divided by delta x, and we start to look at that unit, we're going to have a meter per second per square root of a meter. Okay, if we start simplifying all of that, we can actually get to the point where we end up with a unit that is square root of meter per second squared. So that's what we would place in, having problems with the stylus, that's what we would place inside the parentheses, and that would end up being the equation for the line. The other way to think about this is, instead of trying to isolate the unit here, we can simply look at what this equation looks like. So v equals 2.0 times square root of x, and we can go back to our equation list and we can start thinking, hey, what equation does this look like? Well, we actually have another equation, one of our kinematics, that is v squared equals 2a delta x, so that's going to be v equals the square root of 2a x. I'm not going to work the delta in there because I'm running out of space. Okay, so that automatically tells me now that this is my slope, the square root of 2a, and the square root of 2a has a unit of square root of meters per second squared. Okay, because the unit for acceleration is the only thing left, so that will go in that space for the unit. Okay, let's look at one more before I finish up this video here. All right. So a student plotted gravitational force acting on an object as a function of center-to-center separation distance. What type of graph should the student expect to get? All right, based off of this, if we think about the equations that we know, we only have one equation from last year that has gravitational force and center-to-center distance. Okay, if you remember, we have the force gravity equals gmm over r squared. Okay, so if we plot gravitational force as a function of the separation distance, that means that we're going to have force gravity on the y-axis, and that is gmm, and this is our slope, times 1 over r squared. So based off of this, I already know that my graph should be an inverse square graph. So in order to straighten the line, I'm going to expect that I'm going to have to plot force gravity as a function of 1 over the square of the center-to-center distance. Okay? And once again, the slope is going to represent the GMM part. Okay? All right. I'm about out of time for this first video here. I've been going for 14.5 minutes, so I'm going to need to shut it down. But this will give you a little bit of a rundown on what you're going to have to expect when you're getting into this, because I don't want to spend a whole lot of time going over all the graphing things, okay? So you guys are going to have to figure these out pretty quick this year. Okay, hope that helped. See you next time.